Going to start revision of first chapter, class 12 maths, relation and function. There are two important points of the chapter is relation, functions. If you remember, in class 11th we have done relations. To understand relation, it is important to understand Cartesian product of sets. We have two sets, A and B. Let A be 1, 2, 3 and B is a set of alphabets ABC. Now what is A cross B? Is set of all ordered pairs. We are taking A first, so we are going to write down elements of A first. 1A, 1B, 1C, 2A, 2B, 2C. Same way, 3A, 3B, 3C. So how many elements are there? See, there will be 9 elements, 9 ordered pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So to know the cardinal number of the set A cross B, you have to check how many elements were in A, 3 and B, 3. So total number will be 9. This is about the Cartesian product set. Now, what is relation? Relation is a way to relate the elements of A with B. So we need a particular definition of the relation, right? So example of relation. This is from class 11. That's why I'm not taking very detailed explanation. Only an example I'm giving you. Example, a set relation R is like this. A is related to B. How? That A is brother of B. So, is brother of is a relation. Similarly, you can take another relation, A, B. How they are related? A is sister of B. So here we are in this chapter, especially we discuss about different types of relation and functions, right? Now, what is relation? Now see, the R is set of this type of element. These are the ordered pairs, right? So this means the relation is a what? Subset of A cross A. Okay? Example, I am defining R, how they are related. AB such that A minus B equals to 10. These are the examples from what I was saying, that these were the are these are all examples of your class 12 NCERT book. Please go through the NCERT books, solve examples and unsolved examples. Now see, this is uh, how R is defined. Now if we are considering A is elements of A are 1, 2, 3, 4. Now you will see that no two element of this set are satisfying this relation. For example, consider A as 2 and B as 4. Now what will be the A minus B? Is 2 minus 4, that is minus 2. So you will not get any element which is giving you A minus B equals to 10. So this R we will denote as empty set, null set, right? So you know that empty set and the whole set, right? These are these two sets are extreme relations. Here we have got this empty set. Now how we will get A cross A? Now if we consider the another relation R as that, how A is related to B, such that A minus B, the absolute value is always greater than 0. Now see, elements of A you will going to consider from 1, 2, 3, 4, right? Is it true that A minus B, the absolute value is always greater than equal to 0? You can consider A as 4, B as also 4. We can consider, right? Now how many elements of A cross A you will get? The cardinal number of this set will be 4 cross 4, that is 16. And the 16, I am giving you the example of these 16 ordered pairs. Now see that R will consider, I'm sorry, this will be A cross A consist ordered pairs like 1, 1, 1, 2, 1, 3, 1, 4, right? Then next will be 2, 1, 2, 2, 2, 3, 2, 4. Next will be 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, right? 4, 2, 4, 3, 4, 4, right? Now you are going to consider when you are going to check, yes, this is the whole set A cross A or not. R is equal to, now check, R is defined as absolute value of any two elements you are going to consider is greater than equal to 0. So why not we are going to take A as 4 and B as also 4. So what we, because 4 4 is an element here, ordered pair, right? So you can check that yes, every element. So maximum value of the element is here 4 and 4. So what will be the 4? 4 minus 4, which is equal to 0. So that's why we have taken the relation as mod of A minus B greater than equal to 0. Okay. So you are going to that this is satisfying. So what we are going to write down R as A cross A. So this is clear that empty set and A cross A are these are known as the two extreme relations. So that's why R is always a subset of A cross A. That's the definition of the relation. So in this chapter, your purpose should be like that you are going to first tap R. What is the relation set? If you are able to understand the relation set, you are through. Okay. So next we are going to take reflexive relation, symmetric relation, and the transitive relation. Once you are going to understand this, then we will talk about the equivalence relation. So next is, so for your mental revision, make a list like this in one corner. First point, we have taken Cartesian product set, which is denoted as A cross A. Next, we have taken relation, which is a subset of A cross A. So that's why it was necessary to revise what is A cross A. Relation R. And the third is, we have taken the extreme two relations, null set, phi, and A cross A. Now, next we are going to take reflexive relation. A relation R is called, a relation R is called reflexive relation if AA belongs to R. So the mind that this R is not the set of real numbers. When we consider set of real numbers, we consider it like this double line R. So this is relation R. So AA belongs to R for all A belongs to set A. So this is known a reflexive relation R in a set A. Next, symmetric relation. What is a symmetric relation? If AB belongs to R implies BA belongs to R. Example, 3 less than 4. It is a relation, right? Less than. So we are taking R here as, I'm going to write down, R is relation, R is defined as less than. Okay. Now, 3 is less than 4. This relation is not a symmetric relation. Yes or no? Because the reverse is not true. 4 is not less than 3. So this relation is not a symmetric relation. So how we can give a example of symmetric relation? I'm giving you. L1 is perpendicular on L2. So here R is what? R is defined as perpendicular. So that this is the beauty of maths, that you have all the examples you can have. So is perpendicular is the relation, right? So see, if L1, this is L1, is perpendicular on line L2, so L2 is also perpendicular to L1. So this is the symmetric relation. Next is transitivity, transitive relation. If AB, BC belongs to R, implies AC belongs to R, then R is said to be transitive. I'm going to take the example of this using the previous example, is perpendicular. So what R we are going to consider is perpendicular. We have taken L1 perpendicular L2. So please be careful. In the definition, we have taken AB, BC belongs to R. And then if this implies AC belongs to R, then R is said to be a transitive relation, right? So here we are taking L1 is perpendicular L2. This seems that we are taking L1, L2, L2, L3 belongs to R. This implies L1 is perpendicular on L2 and L2 is perpendicular on L1. Symmetric, right? So is this relation is transitive or not? Let's see, right? Now, I am going to draw a diagram for you. L1 is perpendicular on L2 and L2 is perpendicular on L3. This means this is not a transitive relation. Why? If L1 is perpendicular on L2 and L2 is perpendicular on L3, then L1 is parallel to L3. This implies L1 is parallel to L3. This implies R is not a transitive relation, right? So now we must find out a relation which is transitive. Okay, now I am coming to the example, back to the symmetric, less than, right? This. Now let's see that is this relation. R is less than. Now let's consider A, B, B, C belongs to R. This implies A is less than B and B is less than C. implies AC belongs to R, or you can say A is less than C. I'm giving you a real example. 3 is less than 4, 3, 4, 3, 4, and 4, 5. Let's see. Or 4, 6 belongs to R. So this implies 3 is less than 4 and 4 is less than 6. So combine these two. 3 is less than 4, 4 is less than 6 implies 3 is less than 6. And this implies R is transitive. See that you have to concentrate on your given relation. Without the relation is given, we cannot check that R is transitive or not, symmetric or not, or reflexive or not. You can ask me that you have done the identity relation in class 11. Identity relation means it is not going to change the element. Any relation on that is same. For what is that? The AA belongs to R. So what is the difference between the identity function and identity relation? You can see in NCERT book. This is given, written there, and I will also explain when we are going to do functions. Okay. Now the thing is that let us see the sequence where we have started. This is the sixth point we have done, that transitive relation, right? Now the seventh will be a relation R is known to be an equivalence relation. So I should highlight this the different color I should use to highlight that. Equivalence relation when R satisfies to be what? Reflexive, symmetric, and transitive. To check that R is an equivalence relation or not, you have to first check, is it reflexive, is it symmetric, and is it transitive? Example, this is again an example from your NCERT book. The problem solved there, given solution is given there, but we should understand the what is the how beautifully the example has tackled here. See, the given that the relation is in a set of triangles, right? So we are going to consider capital T is set of all triangles in a plane. When all types of triangles are there, whatever you know about the triangle, how many types of triangles you know, acute angle, right triangles, equilaterals, similar, all types of triangle in a plane, right? And R is the relation given that the two triangles are related to each other if T1 if T1 T1 is congruent to T2. I hope that I'm sure that you know about the congruent triangles and similar triangles. Similar means they look same, and congruent means they are equal in all respect. Their angles are equal and their sides are also equal. So T1 is related to T2 if they are congruent to each other, right? This is how it is defined. Now, if we consider if we consider this R, then we have to see that this is an equivalence relation or not. So if we are starting with the checking that it is reflexive relation or not. So if T1 T2, we are taking all these pairs, T1 T1 belongs or not, right? If this belongs or not. Now to R, belongs to R or not. Now see, if we consider T1 as a triangle, so T1 is always equal to T1. So T1 is congruent to T1. So every triangle is triangle to itself. So that's why T1 T1 implies T1 T1 belongs to R. Next, to check that it is symmetric or not. So if T1 T2 belongs to R, this implies T1 is congruent to T2. This also implies T2 is congruent to T1, and this implies T2 T1 belongs to R. Right? T2 T1 belongs to, right? So T2 T1 belongs to R. Done. Third, we have to check it is transitive or not. So if T1 T2 T2 T3, we are taking these two pairs, belongs to R. This implies T1, by definition of the relation is given here, T1 is congruent to T2 and T2 is given congruent to T3. So we can write down T1 congruent to T2, T2 congruent to T3 implies T1 congruent to T3. This implies T1 T3 belongs to R, and this implies R is an equivalence relation. So this is about the relation, and you have a number of questions given in NCERT book. There are two main points you have to note down, which is you need to revise. First, A type of problem. See, this is very easy, that in the given question that you try with solving the questions, but you will get two types of very different questions there. First is question asked like this: give an example of a relation which is reflexive, symmetric, but not transitive. So you should practice preparation of this type of examples. Reflexive means 1 1, A, 2 2, B. This type of pairs belongs to R. Symmetric means AB belongs to R, implies BA belongs to R, but it is not transitive. Means if AB belongs, BC belongs to R, AA, AB, BB, CC, this type of elements belongs to R. This shows that this is symmetricity is there, reflexivity is there, but not transitive. So how you are going to define R? So you have to learn this type of examples, that how we can prepare this type of examples, right? It is reflexive, symmetric, but not transitive. This means we have to drop some of the elements. You consider the sets 1 2 3 or ABC like this, define a relation there, and first you write down R. R means the ordered pairs it is consisting. If it is consisting AA, BB, CC, then it's reflexive, right? It is consisting AB, BC, CA, AC, this type of elements, okay, it is symmetric. But you have to drop some of the elements which is not R is not consisting, and you have, why deliberately you have to drop, because to show that this is not transitive. So this is one thing. Another thing that you have to, second is B, you have to consider like this. First thing is to give some example that it is satisfying some of the properties, you know, right? And you will get a question in the NCERT book, first exercise, that R is given, right? And either it is given reflexive, symmetric, you can check that it is symmetric or not, reflexive or not, but it is written in the answer it is transitive. So how you are going to check your answer? You will get the, okay, the answer is given wrong, but the answer is not given wrong. It is neither reflexive nor symmetric. So you don't have the elements to check it is transitive or not. So when you cannot check that it is transitive or not, so you will get the answer is given it is transitive. So we will take up this type of problems in our second lecture. So because the elements are not enough to check uh, in R, so that it is transitive or not, and then how and why we are going to write down answer that it is transitive. So this type of problem, these two types of problem we are going to take in the second lecture, when we are going to take up the questions from the book. Now next is, that's all about the end of relation. Now next topic in this chapter, very important of this chapter is functions. We have done in class 11 and the types of functions. Type of functions. And I am going to highlight the point which is very important, right? This is the heart. I suppose you understand the meaning. And soul. Of your class 12th maths. If you are able to understand functions and the types of functions, you are through with the continuity, its graph, its differentiation, maxima, minima, increasing, decreasing, integration, differential equation, everything. This is the heart and the soul. So what is a function first of all? So we are going to define, we are going to take functions. What is that? This is the correspondence. This is a spatial type of relation between two sets, x and y, say, which gives for every element in the domain, that is capital X, has a unique image in the codomain. So this is how the function is defined. This is very important. So when a relation is a function and when is a function is a relation, you have to understand that. Every relation is not function, but every function is a relation. I'm giving you a very important example that you have a mobile number, say 9451617, and 3, how many digits are there? 5, 6, 7, 8 and 5, 9. So 10 digits number, phone number. And this, with this phone number, you are connected to n number of, you are related to n number of people, your friends, your family members, n number, right? Your friends, your colleagues, your teachers, your helpers, right? This is a relation because with this you are connected with so many people. So images are very here. If this is x, this is your y1, y2, y3, y4, y5. This is a very simple example. 6, you are 7, you are 8, y9, y10, y11, y12. I'm only 13 I am mentioning, but you know that you have n numbers of relatives, your friends, your colleagues, your helpers, your teachers, n numbers of people you are related. So this is a relation. This is not a function. A function is a procedure. It is a correspondence. It is a rule which is connecting you with a unique element. So image must be unique. Now I reverse with the example. You n number of people are related to a mobile number 94516. 94516, and then which number I have taken? 717 359. 17359. So how many people are relative with this? Sorry, uh, this will be this will be 94516, 94516, 516, and then 17359. 17359 is related to, this number is related to y1, y1, tell me, y1, y2 with one number. There are so many are related with this number, that is y1, y2, y3, y4, y5, 6, 7, 8, 9, 10, 11, 12, 13 I am taking. Right? So these 13, I am coming back to, again, coming back to the example, this one, y1, y2, these 13, reversing only the process I have reversed here, that these are from y1, y2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These 13 people are related with, see, how many numbers? Only one phone number, your phone number, right? So this is function, because all these has a unique image, uniquely related with that. So this is the difference, basic difference between the relation and function, right? That every y1 has only one, y2 has only unique phone number, they are related. So this is a function. Now this was about class 11th. Now what is class 12th is giving you? Class 12th is giving you that types of function, types of functions, that is 1 or known as injective function. एकदम लिटरेरी मीनिंग से चल रहे हैं, इंजेक्टिव और 1 सो करस्पॉन्डेंस मस्ट बी 1 to 1. Function f is 1 from x to y. It has 1, 2, 3, 4, and here is the element. How many elements? A, B, C, D, E, F, G. Now see, 1 is related to, say, 1 is related to B, 2 to C, right? 3 to D, and 4 to E. Okay. The correspondence is 1 to 1. 1 is related to B. Whatever the relation, we are not bothered for that. We are only showing you by the arrow diagram that 1 is related to B, B is related to C, 2 is related to C, 3 is related to D, and 4 is related to E. Now see, there are two elements which are not the image of any element in X, right? A, G, and F are not the images of any element in X. This is one observation. This is possible for the function, but all the elements of X are exhausted. But it has some images. Unique image we need, and unique image we have here. So one thing you have to observe, that X is totally used. If we are going to not relate 3 with any element, 3 is left, this means this is a relation, this will not be a function. Second, few elements of Y are not used. Okay, not used, not used, no problem. If we have, suppose our element is 5, maybe 5 has the element B is the, this is also possible, that 1 and 5 has the same image. Okay, unique image, same image, this is possible. But then in that case it will be not 1 1, because 2 element has the same image. Okay, so if we are going to give a 1 1 example, so this means we have to delete this. But we cannot leave 5 here unused. So 5 we are going to omit. Now the correspondence is 1 1. Here you can leave some of the elements, but not here. This set must be totally used. This is the scene for the function 1 1. Right? Now, another example. The main thing is that how we are going to show that the function is 1 1. This means if the images are same, fx1 is equal to fx2, where x1 x2 belongs to the domain, implies by the definition of the function that x1 is equal to x2. If this is possible, then the function we prove that is 1 1. This is one way, theoretical way to prove that the function is 1 1. Now, how we can use our graph? Example, we are going to consider y equal to fx equal to 2x minus 5, say, right? Now we have to draw the graph of the function 2x. Draw the graph of the function. That's very easy to draw. First you consider x equal to 0, you will get y equal to minus 5. And then y equal to 0 gives you x equal to 5 by 2. Right? Now draw the graph. The graph is very simple. Say this is 5, 5, 0 and minus 5 point, and this is y0 and this is 5 by 2. We are going to say this is 5 by 2 point, right? So 0 and 5 by 2 point. This will be, point is 5 by 2 and 0. So now we will join this. You have so many ways to draw the graph. Either you take this one, or you take intercept from, or you take slope form, whatever you want to consider. So that's the graph. Now how to check that this is 1 1 or not? To check that this is 1 1, draw a line which is parallel to x-axis. If it intersect your graph of the function at one point, only in one and 1 point, only 1 point, then it is a 1 1 function. If it is not intersecting, parallel line is not intersecting 1 point, 2 points, 3 points, 4 points, 5 points, n number of points, then it is not a function. Example you have at hand. Draw the graph of the function y equal to sine x. That's very easy to draw. It takes maximum value 1 and minimum value -1, right? Minimum value -1. Then what we will do, you start with the this thing, draw the graph of the function. That's very easy. Pi by sine pi by 2 is 1, and sine of 0 is 0. You know the value of sine 45. We used to draw its uh, so sine pi by 2 is more than 1, so we are taking pi by 2, pi, and 3 pi by 2, like this. A very rough figure I am going to draw. Is to start with 0, take the height at pi by 2. This is the point pi by 2, and take 0 at pi, and then -1 at 3 pi by 2, and it goes on like this. So we have the graph will go like this, and here also it is like this. Now see, if we draw a line parallel to x-axis from any point, draw this, and how many points you are getting? Here, 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 all y's are same. This means if this is say x1, this is x2, this is x3, and x3, and this is x4, this is and so on. So that you can write down f of x1 is equals to f of x2 is equals to f of x3 equal to f of x4. But here x1 is different from x2, is different from x3, is different from x4. These are not equal points, because it is an x-axis, it is varying. So this function f is not 1, 1, right? That's a very, very good example. This is not 1, 1. Now next, onto or surjective. A function f from x to y said to be surjective or onto if every element of y is an f image of some element in x. Diagram, see, if for the function you have to exhaust the element of x. So if we have taken 1, 2, 3, 4, and here we have taken a, b, c, d, e, f, g. I am coming back to this example. Now this is a function, this is a 1, 1 function, but this is not a onto function. Why? Because a, f, and g, these are the points, these are the elements which are not the f image of any element or some element in x. So I have the drawing that the a is 1 is related to b, 2 was related to c, and 3 to D and 4 to E. Okay, 3 to D and 4 to E. So these are the element I am highlighting. A, F and G are not used. So F is not onto. Then when it will be onto? You can have the diagram like this. F is here, X is here, Y is here. You have X1, X2, X3. And here is, say, only one element, Y, small I, Y. So X1 to Y, X2 to Y, X3 to Y. This is not one, but this is a onto a function. This function is a onto function. Why? Because Y is exhausted, totally exhausted. We are not talking in this particular example about the oneness, right? Right? We are talking about onto or surjective order. This is, yes, surjective because Y is totally exhausted, and because it is a function, so there is no question about that any element in X is left or not, because it has to totally exhausted X, otherwise it will be a relation. So we are not questioning about that. Okay, another very good example in the real life example I am giving you. Real life example. What is the real life example? You are a student of class 12, say section A. This is a set X of all students of class 12th A. To define it, it should be a well defined set. The class 12th A of Ramanujan, say, or not Ramanujan. I am very fond of DPS Vasant Kunj, Delhi, right? Set of all student of class 12th A of DPS Vasant Kunj, and we have the capacity of 40 student. Say you are starting with Ashish, right? And then Devesh, somewhere is Devesh, and the last 40th student is Yash, say. बीच में कहीं रोहन है, right? So we have 40. Now your roll numbers are assigned for your board exam. So no two student will get the same roll number. Say Rohan has the roll number 7004231. Okay. So no other student will get this roll number. So every element of X has a unique roll number, right? Last up to the 40th. Okay. And this the set of integers. We are taking say set of natural numbers. This function is not onto, because set of natural numbers has infinite natural numbers are there. Okay, but only out of that 1 to 40, matlab 231 before that, and after 231 some of the natural numbers will be used, otherwise all are left. So this is not a onto function. Okay. So how to check that this is an onto function or not? To check that this is an onto function or not, you have to check that range is equal to the codomain of the function. If it is equal to the codomain, then only you will get that range is equal to the codomain, means this is a onto function. Now how to check that range is equal to the codomain and this is onto not, or 1 1 or not, 1 1 or onto or not? So that's very important. Example, this is a NCERT example I am giving you. Y equal to 2x. It is a given function, and the function is given from rate of real numbers to set of real numbers. Now let's draw the y equal to 2x. Now how to find out that what is the domain and what is the codomain, or what is the range of the function? That's very important. Codomain and the domain is given here, but how to check the range? See that all possible value x can take. I am only revising the domain and range definition of class 11th from the function chapter. Domain is all possible value x can consider, x can take. If you are a student and you spread your arms like this, two sides, right? Equal arms. Right? Equal arms. So this, suppose the origin, right? Your head I am spotting. If you spread your hands, so this what shows that x can take the values, all possible values, and this is the domain. And if you spread your arms like this, one like this and another one like this, this shows your range. Right? Now come back to this y equal to 2x. I have told you when I was starting to describe types of function, that is, this is the heart and the soul of your whole maths syllabus, calculus particularly. So if you are going to draw the graph, you are going to draw it like this. And now draw y equal to 2x, means 1, x is 1, y is 2. X is minus 1, y is minus 2. And if x is 0, y is 0. So it will pass through the origin and the graph is like this. The function is 1 1. Why? Draw a line parallel to x-axis. It intersects at only one point. Is it onto? Yes, it is onto. Why? This is your x value. It can take minus infinity to plus infinity, all the values of x it can take. There is no harm, not the function is invalid anywhere, right? And y, for yc, it is taking the minus infinity value and the plus infinity value. So we will write down the for f of x1 and x2 is here. If x1 is equal to x2, this is the simple solution techniques. So by definition, this is 2x1, this is 2x2, 2 to cancel. This implies x1 is equal to x2. Right? This implies f is 1, 1. And what is the range? Range of f is equal to R, which is equal to codomain of the function. And this implies f is onto. That's the end of the today's lecture. And we have done with functions type 1, 1 onto, relations, type of relation, reflexive, symmetric, transitive, and equivalence relation. That's all for today.